In this video, we are going to discuss example 19, where we are going to integrate cos cube x times sin cube x. This integration is very similar to the integration we have seen where we integrate cos power 5x. This integration and these integrations are special case of number 1, where one of the power in the trigonometric function is odd. It doesn't really matter whether the other trigonometric function is raised to an odd or even power. In example 17, we have sine raised to a power of odd number. In 18 also, we have an cos raised to a power of 5. And now, we have also a cos raised to an odd number. The method to integrate example 17, 18, and 19 are very similar. They can be referring to case 1. The method to integrate example 19 is similar to the method used to integrate example 18 and 17 in the sense that you just choose one of the odd power in the product and then split it into an even power times a term which is linear in the trigonometric function. For example, you can choose to break sine power 3x in the integrand into the product of an even power times the linear power in sine x. Now you could equally choose cos cube and break it into the product of cos square x times cos x. Either this choice or this choice would allow you to perform the integration in a very similar manner. So to be specific in this example, let us proceed by choosing the decomposition of sine cube into sine square and sine. Similar to example 18 and 17, we would need the identity that relate the cos square x and sine square x. We would choose u to represent the cos term. In this case, u is chosen to represent cos if you choose to break the sine cube into sine square and sine. With this choice, cos cube is then written down as u cube. This expression can be written as this term, which is sine square x times sine x dx. Sine x dx is nothing but just the differential of u with a minus sign. And the sine square x is simply equals to 1 minus cos square x. So the next line would be then written as 1 minus cos square x, and this will just give me du with a minus sign. And I'll simply replace 1 minus cos square x by 1 over u square du. And that would lead to the integrations of u power 4 minus u square, which is then translate into this expression. Substitute in the expression that is represented by u, then we will arrive at the solution to the integrations that we want to integrate. So as a conclusion to example 19, we have shown you how to integrate the product of two trigonometric terms, where each of the term is raised to an odd power. So you can either choose to break the sine cube into sine square x, sine x, or you break the cos cube into cos square cos. Here we choose to break the sine cube into the product of an even power and an linear power. Since we choose to break sine cube into the product of sine square and sine, then we'll choose to replace cos x by u. Then rewrite the expression of cos cube into u cube and sine cube x dx into the product of sine square x sine x. Sine square x is related to the cos square x through the identity. So sine square x is expressed into the form of 1 minus cos square. This product of sine x dx is just minus du. So this integration is now translated into the integrations of u, which turns out to be in the form of a simple polynomial function. Then you integrate this polynomial function straightforwardly to arrive at the final answer.